me 1 sec to share my screen here. This is going to be a little bit of a continuation from last time. Last time we did a little bit of Q&A, and then we started to work through a little bit of fun with actors. So I thought we could continue that today. But especially as we're getting started, if anyone has questions on anything else that they'd like to cover, now is a great time. We're just tussling as we go, and if we don't get to today, we can cover it in a subsequent session. But 1 sec here, I'm just going to grab the Discord link and share that with everyone. There's the Discord link for anyone who doesn't have it. And all right, let me share my screen and let's get started here. So last time, among other things, we were just starting to talk about implementing actors with ZIO. And I think this is, this is a little bit more of a exploratory fun session. We have some of these where it's like a very specific thing of like, hey, there's this new feature in this library that may be useful to you in your like day job, and that's fantastic. But I think we also have some of these where it's more just an opportunity to code together and kind of explore a problem domain. And it's more about the journey than the destination. In this case, there's already a ZIO actors library if you want to do actors with ZIO. And I think for some reason that maybe we'll get to talk about, I think people just find that there's just other ways to do things that they would have done with actors in other framework with ZIO. So even though that ZIO actors library is there, it is great if you want actors. I think a lot of people find that they don't really need actors once they have ZIO. So this will be a little bit more of just us using actors as one domain that we can explore together versus this is going to have a super practical implication of like we're going to submit a PR or start a new library or something. But I think it's fun to explore stuff like this, and hopefully it's also like a little bit of an inspiration to everyone. One, it's fun to explore your own stuff, but also if anyone has a topic they would be interested in or something that they're kind of struggling to think about, it could be a fun thing that we could look at together. I don't know if Damien got all of his issues figured out, but I know there was one person who was kind of, I think, having some issues with like ZIO JSON, and they wanted to kind of do like encoding and decoding in like a little bit of a different way and how to do that. So, that could be a domain we can explore. I mean, there are lots of things out there. That's, I guess, one of the beautiful things. There's like so many things to learn. But today we'll be playing with this little domain of actors, and I'll try to have, I got another screen here where I got the Discord up. So I encourage people to really be active, both with like questions, but also I think there'll be cases where we'll like explore their different design alternatives, and there's not necessarily a right and wrong, there's just trade-offs, and we'll kind of explore maybe between those what we want to do, and we can decide that together. Okay, so where we were starting to go is defining this like trait for an actor. And I think one of the first choices that we have to make is like, what's the basic interface of the actor? And so this, I would say, is probably the like most minimal, at least typed interface of the actor. I guess if we had a totally untyped actor, if we wanted to be totally untyped, we could have something like this, right? So this basically says, hey, you can send any message and we'll just do something with it. So this is like not a very specific type signature, but I mean, that's basically kind of what like the original like akka before akka typed was. I guess that worked, but I think we maybe progressed here. So I think this is probably a good starting point. And I think the first architectural decision we have a little bit that I think we talked a little bit last time is, do we also want to support some type of ask message? And so I think if we did that, let's just kind of explore what that would look like. So let's maybe initially we'll kind of do question. So in the kind of traditional one, this is buy or forget. This is also like sometimes called like the bang operator. And then this one is like, request and response. And this one usually has this like question mark operator. So one question we have for ourselves is like, do we want to support this type of ask pattern at all? Now, one thing, let's just explore the alternatives here. So one thing, let's call this maybe a send actor. And this is just going to have the send method. And then let's try another, let's call it the ask actor. And let's explore a little bit what that would mean. And so this is going to take send. And that's also going to have this ask thing. And so Naveed says, shouldn't ask take a ref? So Naveed, what would the ref be? So typically, I think when you do the ask, the ref of the sender is kind of implicit in who's sending it. So it's not. It sounds like you're saying, if I'm understanding you right, that we basically have like a message that's an in, and then like a sender that's some like actor ref, and we haven't even gotten to the concept of an actor ref yet. But I think typically that would kind of be built into the message, or at least that's how I think I would think about that. And we're kind of getting a little bit ahead of this concept of kind of an actor ref that's separate from the actor itself, which I think we'll get to. But let's take things a little bit one step at a time here. So this ask actor would take an in message, and it would give us back some actual value, so that if like the message was asking for the temperature, this would actually give us back a double that had the temperature. Now, one thing that we can notice from that a little bit is this signature isn't really powerful enough to let us do that, because we don't have a way of saying based on this end message what the type of the output is going to be. So we could instead, this is actually like a case where we could have a like bit of a higher kind of type here. So this looks like fancier. And then this ask now takes like a message of A, and maybe if we want to be even more explicit, we call this like an out. And then it gives us that out value. And then this can become, you can take a message of any, or you can take a message of nothing here. But essentially, if you're going to send it, then I don't care what message you're giving me. I'm just going to process it however I'm going to process it, but I don't need to know the type here. If we wanted to, we could put it here, but we don't need to. So I think we have a little bit of a choice here of like which one of these we want to have. The actual ZIO actors implementation has more of this structure where you can send and ask, and that can definitely be nice because it makes it easier to do this like request response style, and particularly with ZIO, we can implement it in a non-blocking way. At the same time, even though this is not going to semantically block, what this does mean is that if we have, let's say, actor one sends an ask message to actor two, it means that actor one can't process any new messages until actor two responds. So it lets us introduce a little bit more linearity, you could say, into our system. But I think at least some people, some things I've like read, or people I've seen give talks on actors say, well, that's not a a good pattern, and they've kind of phased out the ask in favor of the send pattern. And I think that sometimes makes you do a little bit more work as a developer in kind of writing your application, because everything is just in terms of these asynchronous messages. But sometimes those constraints can ultimately be good things, a little bit like, if you're writing with Rust, that's a little bit of a pain sometimes dealing with the borrow checker in memory, but the end result is you get a program that's kind of very performant without you having to kind of write the program and then after the fact do a ton of optimizations on it. So since we're kind of doing stuff together, maybe let me put it out to other folks a little bit. Which one of these should we do for our little toy actor library that we're developing? Does anyone have a point of view? If you aren't already aware, there's a Discord. I placed the link before, and that's a great place if you have any feedback there, to just raise your hand, or you can do just like raise your hand here, or we can be quiet as a group. Okay, I see. Okay, so Baldwin says he's happy with either one, which is a very nice answer, but also not as helpful right now when you just pick one. And Naveed says, is the out type serializable? So right now there's no constraints that any types. No, you're fantastic. No, so right now there's no types that there's no constraints that any of these types are serializable. So I think that's something that we'll get to. I think one of the nice things about actors is they can scale pretty nicely from kind of the local case to distributed case. So I think that's definitely something that, depending on kind of how far we get in our explorations here, we definitely want to address. We could potentially put some constraints on that, but definitely right now we have no constraints that anything is serializable. Okay, so someone says ask actor. Someone says, okay, so it seems like a bunch of people are interested in the ask actor. And actually, someone said, can we do it in terms of promises? And yeah, that's kind of what we're going to do under the hood. So why don't we do that? I think partly it'll maybe just let us like play with a little bit more ZIO machinery. So that's always fun. And I guess one thing we can always do is, if we later on decide it's terrible, we can say, oh, the ask is deprecated, or we can just kind of push in our documentation that like, maybe it's a better practice to use the send versus ask. Okay, so then I'm going to get rid of this send actor, and I'm just going to rename the ask actor to actor. And let me make sure that this is actually compiling here, because that's always a good check for myself. Okay, so we've got, I think, our basic interface for an actor then. So let's just review it. So an actor is something that accepts messages, and each message that it gets is going to be parameterized on some type. That's basically going to be the output type. And one thing, you may have seen this, like you can just do the underscore here. The underscore here actually doesn't have any significance really. So if I feel like this is like more semantically clear, I'm free to do that. So yeah, you can decide if you like that or not, or maybe we just call this out. But basically, the actor is going to accept messages, and each message is going to be parameterized on some out type that basically says what type of response the message gets. So if we wanted to, we could even maybe we should call this response. And so we're going to have two types of interfaces we're going to support. We're going to support just a send. And I think since this is covariant, we can replace this with, let me just make sure this is actually, I'm compiling the right thing here. Hold on. Yeah, so this is not the right, hold on. Let me exit. Okay. I was like, this is compiled a little too fast here. Projects. I think we're in Q&A. So, questions, answers, project, questions, answers. Now let's compile. Okay, now this shouldn't work. Right. Now let's. Okay, good. Okay. So we can accept messages that are just fire and forget, and then we don't care what that output, the response type is at all, and we'll just process them. And you can also ask us for, again, this is just totally semantic. It's just a message with a certain response type, and we will give you that response type. Okay, so now that we've got that interface, maybe a first thing that would be good to do is kind of have a way to make our first actor. I think as we get bigger here, we'll I probably get to a point where we say, well, we shouldn't just make the actors, we should like make the actors from an actor system, and we'll have some concept of an actor system, but I like to kind of take things incrementally. So we might just want a way to create one of these actors. And I think that will also just be a good opportunity for us to flesh out the implementation a little bit, and hopefully we can get to like having some type of example of an actor. So let's think about maybe a make method here. And I think this is not a bad idea here to say this is going to take something that's, we're going to have one thing that's a message. Actually, I think we just do, we decide what we like to do. Let's see how we can do this. So maybe we're going to think a little bit about the interface we want to have here. Maybe we want to think about having like a function here. So maybe this is something like a function from message. And let's think about what we would want it to, would want to be able to do here. Boy, Copilot can really get ahead of us here. So we'd like to be able to, why don't we actually, before we even do the make method, let's think about creating a particular actor, and then let's think about how we abstract over this a little bit. So what if we want to do something like make temperature actor, say. And so let's maybe call this object example. And so let's think about what this like message might be. So what if we said we're going to have sealed trait temperature message. I think this kind of thing has been like one of the classical things. And so this will be parameterized on a response. And then we can do like object temperature message. And maybe we do something like final case class set temperature, the value, and that there's going to be no response back. And then maybe we'll do something like case object get temperature, and that'll expect back the value there. Does that part make sense to everyone? Oh, do I already have an example here? Let's see. Oh, I think somewhere else I have an example. Object saved. Okay, we got random. I'm just going to comment this stuff out to free myself up a little bit from namespace collisions here. Now I think this should all be happy. Okay, great. Okay, So if I wanted to make an actor based on this, so why don't I define something def make temperature actor. And so let's think of what this would return. So it seems like it's going to return a ZIO. Maybe let's start with any nothing. We can question that in a minute. And it's going to return an actor that accepts temperature messages. And maybe even if we wanted, we could say something like trait temperature actor extends actor temperature message, right? And then we're going to need to implement these two methods up here. And let's see if we can do that. So we're going to take in temperature message here. And here, this will be temperature message any. And so, yep. And this will be a temperature message response. And we'll give this back. We need to actually implement these things. So we'll give ourselves question marks here. And give ourselves here. So then let's just be really simple to start with. So we could say ZIO dot succeed new temperature actor. Now, clearly we're going to need to implement this, and we may need some stuff for that. So that may need to change. But let's kind of take that as a starting point. And so here then, I think we'd say, well, we want to maintain some state here. And the state, make this a case class. So let's say here my state is going to be a ref of a double. Oh, and I see we got one question. Can you explain a bit on why the actor trait has message type as contravariant? Sure. So the reason it's contravariant is because this only appears as an input. So we did a couple of sessions a while back on variants, and maybe we can do another one sometime. But basically, contravariant means something is an input only, and covariant means it's an output only. And so here, if you look at the message, the actor only ever receives these messages. The messages never appear in the output here or here. That's why, and just having this contravariance is going to help with type inference, and it's going to kind of help the compiler work for us. So that's why we do the contravariance there. And then Naveed had a question, do we really need this to be a ref? No, we probably don't, because we would say one of the things about this actor is that it's going to be just operating this single thread, so it's not going to be concurrently accessed. I think at least as a starting point, I am just going to stick with using a ref just to kind of keep us in that purely functional world of, like, if we're having state that we're changing, we're just describing versus doing it. Definitely for performance and optimization, we could change that. That could be like a var or something, but just as we're kind of sketching things out here, just kind of keep it clean until we want to make it not. Okay. And okay, I think I answered that one. Okay, so it seems like we're gonna need a ref here. And then I think the other thing we're gonna need is maybe we call this just the state, is we're gonna need essentially a inbox that's gonna be a queue of these temperature messages. And so clearly this is going to have to be updated. But let's think about if we, and this is a queue of temperature messages. Okay. So clearly we're going to have to do a little bit of work here. But let's think a little bit about how we would implement these, and then maybe we can go back and implement this. So if we wanted to send a temperature message, then I think this then in this world becomes pretty straightforward of we just offer it to the inbox. And I think the only reason this is, I think, going to return a Boolean that says, yeah, whether we successfully offer it or not. And the only time we wouldn't successfully offer is if it was a dropping queue, which we're not going to use. So I'm just going to do unit there. So we're not going to worry about that. Okay, so this is what it would mean to send a message to the actor. Let's then play with the ask a little bit. So the ask is going to be harder because we need a way to wait for the result in addition to just offering it to the inbox. So it seems like what we want to do is one, I guess, clue is when we want to be able to wait for something, and it's just one thing we're waiting for, a promise is kind of the go-to tool for us. So it seems like here we might want something like, first we'll make a promise. Hey, Damien, give me 1 sec. Let me see if I can grab a link for you. Oops, let's see. 1 sec. All right, just posted the link. I think you have to do a little sign up thing. But I see we were actually talking about your little JSON thing before. Maybe we could explore that sometime in one of these sessions. But anyway, here, so it seems like we want to make a promise that is going to have a spot for the response when it's available. And then what we're running into a little bit is then what we'd like to do is we'd like to do something is we'd like to basically offer to the inbox both the message, but we'd really want to offer the promise as well. And then here we could just say response in promise and await yield the response. So this is going to compile right now, but right now it's not really going to do what we want it to because we're not putting this promise in the inbox, so it's never going to get completed. So we're just going to wait around forever here. So we could kind of think that what that's telling us is that this inbox is really, it can't just be the messages. It has to be kind of a tuple, basically, of this temperature message and a promise. Let's see if I got it right. And probably that would be nicer if we made that into like a case class or something, just because that's kind of a big type. So maybe we'll do that in a minute here, but I think I'm going to try to push forward a little bit here. So if we did that, then we have to restructure this slightly. There's another thing, maybe this shouldn't actually be a promise. Maybe this should be like an option of a promise. And the option, well, so I think so Naveed raises correctly. I think this shouldn't actually be a temperature message, but this should be basically the out type, but we don't know what the out type is. So this may have to just be any for now, and we have to ourselves enforce this guarantee that this type matches up with this type. But yeah, that's exactly right. And so we could go 2 ways. We could either just make this an option, or we could just kind of create like a dummy promise here. Maybe I'm just going to start off by kind of creating the dummy promise just to kind of get us going with this example, and then I'll kind of note that as a like opportunity for us to refactor. So then here, we can now offer the promise. Oops. And then the difference here is just going to be that instead of waiting it, I'm just going to immediately return. So let's take a look at this. We may have some issues with types here because we're kind of using knowledge we have, the compiler doesn't have. And I think you can see that a little bit. So I think we actually want this, because the promise is invariant there, I think we actually, yeah, we want that to be an underscore versus any. And now all of this is happy. So we've implemented this interface. What's the big thing that's missing here? Well, this guy, right? We essentially, I mean, one, we haven't created, this is not implemented. But two, we've got kind of the logic of like offering to the inbox and waiting for the result, but we don't have the logic of kind of the actor itself that's behind the inbox. It's actually processing the inbox messages. So let's work on that here. So we know we're going to need to make some of these things. So we need some ZIO stuff. So let's do that here. So if nothing else, we definitely need these two things. So we need a inbox here. And one thing, by the way, we notice is we don't actually need the state here at all. Because this is just interacting with the inbox. So we'll still probably need that somewhere, but we don't necessarily need that now. Okay, so let's say for inbox in QUEUE, we can decide a little bit whether we want it to be bounded or unbounded. I'm going to make things easy right now. Not worry about what the bound should be by just making it unbounded. So we're going to need an inbox. And then the very simplest thing we can do is we can return a temperature actor that uses that inbox. So now we've solved the question problem, but we still don't have the logic, of actually processing these inbox messages. So let's work on that now. So if we do it kind of specific for this temperature actor, we could say, okay, well, we're just going to want one fiber. Right? A fiber is kind of going to correspond to an actor. If a fiber is like a unit of linear execution. So we're going to have one fiber that just forever is going to be taking things from this inbox and processing them. So let's kind of explore that a little bit. So we could say inbox.take.flatMath, and then indeed, this is going to give us a message and a promise. Oops. And then maybe the first thing we want to do is we want to match on the message and decide what to do with it. And so we have these two types of messages. So we have a set temperature value. I think that first part's right, second part's not. And then we have a temperature message dot get temperature. And we need to do something with those. And there's a question, always one fiber per actor. Yeah, so I think if we think about what a fiber is and some of the guarantees an actor is supposed to have, that's right. There really should always be one fiber per actor because generally, if you think about like what an actor is supposed to be, an actor has kind of one linear set of executions, right? The whole point of like an actor is it linearizes things through its inbox, that it just processes one message at a time. And it may introduce concurrency in other ways of like this actor, if it needs to be adding a bunch of numbers, maybe it's going to send messages to 10 other actors, and then those actors are going to send messages back to it, and it's going to use those to put together whatever, computing the prime number or whatever fun math thing we have, but that each actor linearly processes one message at a time. And if we think about a fiber is essentially a very similar thing of a fiber is like a thread, right? It does one thing at a time. And so you may have concurrency in your program with multiple fibers doing different things, but each fiber is only doing one thing and then another thing and then something else. So I think it's actually a very natural fit that way. And actually, if you go back to like the series we did on like the ZIO runtime, you can actually think of like the way a fiber is implemented. You can think of it as a little bit of like a nano actor. So yeah, I think that's a pretty natural fit there. Okay, so we're going to take each item from the inbox. We're going to do some processing. Right now, we're just going to question what the processing is. And then we just want to do that forever. We're going to want to do that as long as this actor exists. And then we're going to want to fork that process off. Now, there are a couple of things. Obviously, we need to fill this in. The other thing that we could do here is, I think instead of using just fork, I'm going to use this operator called fork scope. And what this is going to do is it's going to introduce a requirement for a scope. So this is now going to change to having a scope there. And what this scope is going to represent is the lifetime of the fiber. And so essentially, whenever I close this scope, I'm going to interrupt this fiber. So one of the ideas that is also in actors is that right, you can shut them down. They kind of have lifetimes. Like, yes, this is processing from this queue forever, but like eventually want to shut this program down, or we don't care about the temperature anymore, or what have you. So we may build higher level things on top of this, but I think this is kind of a nice, just easy way to start to introduce that concept to our program. And this is an operator I really like. I'd recommend people check out. But a lot of times, if you need to just create some fiber, if you just know you're going to kind of fork do something, then you're going to join it yourself, then like fork is great. But sometimes I see people using fork daemon when they want to create like a background process. And I think most of the time, if you're using that for a background process, you're actually better off with fork scoped, because even though it is a background process, it should probably have some lifetime. It should be scoped to like, maybe you're creating this background process part of like a service, and like it should be scoped to like the life of like the layer that constructs that service or something like that. So it's just a nice operator. I'd suggest you take a look at if you haven't already. And now we're almost done here. All we need to do is like our actual logic. So this is where we are going to need some kind of state here. So maybe here I'm going to just bring back the ref that, yeah, let's say it starts off at 0. We can make what it should start off at. And so then if we set the temperature, then we're just going to set the temperature. And at least as a constructor right now, this promise is kind of a dummy promise, so I don't even need to do this, but let's say we're going to do this. And then if we want to get the temperature, then we're just going to get the value from the ref, and then we're going to complete the promise with it. And then let's see what we got here. Right. So this is where we're going to have to use a little bit of our knowledge here of this promise. Right. We're kind of relying on some private knowledge that we have, that what we can express the types here, because this queue is just full of all these different temperature messages that are of any type, is just that we know these two types match up, but the compiler doesn't. So I'm going to need a little bit of a we need to kind of show the compiler that, and maybe either in this or in a subsequent session, we can look at, see if I can do that, or maybe I will end up turning it back into a promise of any, but we can look at kind of some nicer techniques to do that. Why don't I just do, let's see, And this is now climax. Thanks. Okay. So we may run into problems with that, but we'll see if we can try to clean that up. Okay, so let's try to actually let's try to write a little program with our temperature actor here and see if this actually works for us. So let's do for actor, and so just import our example. Actor and make temperature actor. And then, yeah, maybe this is a nice, let's make a couple of other methods for ourselves here, say. So let's do, we had the little bang thing. Let's just send. And then we'll have the little question mark thing that'll be ask. Okay, so then we could do actor, set temperature, sure. And then, yeah, let's try to see if we get this to work. Okay, so let's try running this program and let's see what happens here. Okay, and so we got temperature is 42. So we've got our first actor working here. We'll just check on questions. So Naveed says, is a fiber's lifetime bound to a single thread, or can it shift to a different thread? So that is a great question. So a little bit different here. So a fiber can be executed by multiple threads over its lifetime. So it's not a one-to-one correspondence between fibers and threads. My point was more that both fibers and threads represent linear chains of execution. With both a fiber and a thread, you know that like if a fiber did two things, definitively one thing happened before the other thing, or vice versa. Just like with a thread, if a thread did two things on one thread, either A happened before B or B happened before A. Versus if you're on two threads or two different fibers and two different things happen, it doesn't necessarily make sense to say whether one happened before or after the other. Maybe they happened kind of at the same time. And then there was a question, yeah, can you please explain what's more the importance of forever.forScoped? Sure. So let's kind of take them one at a time. So let's look first at the forever. So if all I did was fork here, then what this means is I'm just saying do this once. And so if I try to run this program here, it's not going to do what I want because it's going to process the first message, but it's never going to process the second message. And we can add a little debug statement to show that. Processing set temperature. And debug processing. So if I don't do the forever, this code here is going to run only once. And so I'm going to take the first item, which was the set temperature. I'm going to process that. I'm going to set it. But then I'm not going to do anything with everything else from the inbox. So it's just going to sit there. And that's why my program is just kind of hanging for me. So the forever is just basically a way of just saying, do the same thing over and over again. And so by doing that, I ensure this is going to, I ensure that this is going to keep processing messages as I have them. And I can just add more and more messages here. So if I wanted to do like, I just wanted to like process a bunch more messages, well, that's fine. It's going to process them all. And so you see it did the right thing and kind of used the last one. So that's why the forever is important. The fork scoped is really just, I think we really need it here. Yeah. So for a simple case like this, we don't need it, but what it's doing is just giving us more control over the lifetime of this fiber. And the idea here is that when we've done this part here, so sorry, let me actually step back for a sec. So the first thing that's really important is we do some variant of fork. If I don't do any variant of fork here, then this program is not going to work for me. So if I just do this, my program is going to hang. And the reason is that I'm just doing this right now instead of I'm doing it in a different process. And so I'm just trying to take from this inbox that doesn't have anything in it. And so I'm just going to like wait for the inbox to have things in it. But because this is now like my main thread of execution, my main fiber, I'm never getting past this. And so I'm never getting a chance to get past this line here and get to actually offering some things to press. So that's why it's really important to do some variant of fork. And there are a couple of different variants of fork in ZIO. There's fork, there's fork daemon, and there's fork scoped are the big ones. And those ones are basically just helping you control what's the life of this fiber you've created. Because when I do this fiber I've said is going to go on literally forever, right? And so there's this question of, well, okay, yes, you want it to take messages from the inbox forever because you want, maybe there are going to be more messages in the inbox, but do you want it to go literally forever? Because let's say that we rename this to like my temperature program. And then my whole program is val run is equal to my temperature program. And then let's say ZIO.debug doing something else. .pn. And let's say delay that 1 second. And so this is like my whole program. And so if I run this right now, so it's done all the temperature stuff. And now I'm just doing something else 10 times, right? From taking up this 10 seconds here. And do I really need this fiber to be sticking around waiting for things from the temperature actor? And in this case, it's just one fiber suspending on this thing. It's not a large cost. It's not the end of the world to do that. But especially as we have like kind of larger programs and we like think about things like this, what we kind of like to be able to do here is say, okay, like at this point, I'm done with the temperature actor, right? I created it. It did everything I wanted to do. It gave me its result. I'm done with the temperature actor. And so the scope is really nice for that, because when I do fork scoped, that's what's going to introduce this scope into the environment. And so then if I want to, if I don't do anything else, it's just going to use the application level scope. And so it's going to shut down this temperature actor when I'm done with the whole application. But what I can do is I can just do a ZIO.scoped around this. I can say, hey, here is the life of this temperature actor thing. And maybe let me see if I can add a little statement. Let's say on interrupt, ZIO.debug, temperature actor shutting down. So let's try running this now. And so we see I did this at the wrong place actually. I shut it down too early because I shut it down as soon as I made it, instead of I really wanted to shut it down here after my whole temperature program was done. So let me fix that. And let me show this. Okay. So see here, we got kind of exactly what I think we would want of the temperature actor did all of its stuff. It gave us a temperature. And as soon as we were done with that, it shut down. And in this case, shutting down was literally just, I printed this debug statement. But you could imagine maybe this actor is like guarding some type of resource. And like maybe as soon as we created the actor, we like created the resource, or we created like a connection or something like that. And so when the actor's done, we want to shut it down there. Okay, so I'm going to take this back out. I'll get rid of the fork scoped. And so Naveed has a question of, is this flexible for us to implement something like graceful shutdown? Yeah, I think definitely. I mean, here we're kind of, I guess our version of graceful shutdown right now is, we're basically what fork scoped is saying, you could think of is the definition of graceful shutdown for this actor is to interrupt the fiber. Now, we could say maybe that's maybe we want a more graceful definition than that, and we could definitely build in versions of that, and maybe that could be a fun exercise for us to explore right now. But a scope is just something that you can close, and when you close it, can do different things. So here we're saying what we're going to do is we're going to interrupt this fiber. But I think you're right. Maybe we want to do a little bit more of a graceful thing. So maybe that could be a fun little thing for us to do as we kind of as we're doing this. Okay. Yeah. So I see one more person is typing, but yeah, maybe let me explore that a little bit. So I think one thing you could say, if we build on Naveed's point, is that right now, if we're using this fork scoped and we close it, I think here we're actually kind of fine because we ourselves are closing it when we know we're done with this thing. But maybe we want to make sure that we don't interrupt the fiber in the middle of processing a message, but we just say don't process any new message. And I see, okay, so this other question is, how do you achieve an ordered shutdown scope to shut down all the components in proper sequence? Yeah, so that's a great question. We're getting into a lot of good resource management stuff. So the basic answer is that ZIO is going to do that for us almost automatically with scopes, because these scopes follow a rule that when a scope is closed, resources are released in the reverse order of acquisition. And that ends up being a really useful paradigm, because if you think about like how things typically work, like imagine that you like first open network connection, then open database on remote server. Clearly, we've got to release them in the opposite order, right? If we close the network connection first, then we don't even get to talk to the remote server anymore. We've got to close this, and then we've got to close this. And so let me actually even create a little example for us on this. So let's call this maybe val scope example. And so I'm going to use another operator. Well, let's create a little helper here. Let's create something called resource. And I'm just going to use acquire release here, describe a resource. And I'm just going to say, we're going to print acquiring when we acquire it. And then we're going to print releasing when we release it. And so now let me just create a program that does resource like A and resource B. And resource C and unit. And so let me change my run to be that scope example. And let's see, maybe I'll pull this up here just so I don't have any issues with it being unhappy with values being out of order. Yeah, let me see what I do here. And so see what we get here. And let me make this a little bit bigger. Sorry, I'm bad at remembering to make the screen big. So see, we get exactly that order of releasing resources that we expect. Essentially, I think my experience, and I think most other people's experience working with ZIO, is like you don't really explicitly think about the order of releasing resources. You think of the order of acquiring resources, and usually that's like implied by a logical order of like, B is going to blow up if you try to acquire it before A, or B just takes A as a parameter, so you have to acquire A before B. But essentially, as long as you follow that logical structure, you end up releasing things exactly the way you need to. And if you get into like that very fancy situation, then you could create like a promise if you want to make sure, well, this needs to get done in a different order. But I would say it's a really unusual, and I mean, to be 99.9% of the time, it's a really unusual situation that you need to kind of do manual stuff around resource ordering. Okay. So I think we just about at time here, but I mean, I think this is a really cool session, and I love the engagement on like which kind of actors we should work on building, and I think we got into a lot of like cool things of like scopes and fibers and forking. So maybe that's just a good like lesson that like sometimes maybe it's easier to like you're seeing something and you have questions versus just you say in the abstract do you have questions about things. But I think as we look at this, so I think we definitely say like the good of this is like we did implement an actor here. I think we somewhat intentionally kind of implemented this one ourselves, and you could say this actor kind of right now mixes up some what you call kind of our business logic, right? This is kind of, you could say, well, some of this is our business logic, like basically this part and like this part is our business logic. But then we also have a lot here that is kind of just like general actor mechanics, right? Like all of this is not really about temperature at all, but just about kind of the way we're just going to offer things, the inbox, and a good amount of this of like the forever, the fork scoped, the inbox. This is again just about the basic structure. So I think the next thing we'd want to do here is try to split those out a little bit more and basically give you a way to define an actor where you don't know about any of this stuff, and you basically just implement this business logic stuff. But at least I think sometimes my attitude is like feel the pain or like do the ugly thing a little bit first. So like I think this was nice, at least from my perspective, to just like get a chance to kind of actually do it, and we got a working example, and we kind of did all the things, and as we went through it, we saw some things that like are definite opportunities for improvement, but it's sometimes easier to like do the improvement once you have some version of the thing versus when it's you kind of don't have anything yet. And I see there's a bunch of actually people are excited about this idea of trying to get this to be something that can communicate across JVMs. So I think that's a really cool like kind of goal for like a bigger project that we could do over a number of weeks. So I think there's definitely like steps along the way there of I think first we have to abstract this out. I think then we probably need to introduce the concept of like a actor ref as opposed to an actor and an actor system. And we'll need to look at having constraints so that these things are serializable. But I think that could be a really cool thing. And I think maybe that could be a fun way also for us to maybe bridge from that into doing some things with like some distributed algorithms and stuff. I know we did that one session on the ZIO Maelstrom, I believe it was before, that kind of gives you one way to do that, but I felt like that was like really like a framework. And I think sometimes it's nice to kind of, do it yourself and kind of build up to that. So I think that sounds really cool. But I think right now we are at about an hour, and it's Friday afternoon now for me, and probably Friday evening for most of you. So I think we'll break it here. But I'll post the source code for this to GitHub for the Zymposium, and we'll just we'll keep going forward with this, and yeah, please send my way if there are like ideas of other things you want to work on. I think it's fun doing this stuff together. So yeah, I mean, it's fun doing things in general, but it's fun doing things that you all are excited about. So yeah, look forward to doing more. All right, have a great day, everyone.